This is the second lesson of the Introduction to Science GCSE on Chemistry. So from last lesson you should have learned the basics around the structure of the atom. So you should know that an atom has two main parts: the centre, which is the nucleus, which is this region here, and then shells around the outside, and the space in between is just empty space. And in the nucleus there are two particles. One is a neutron, which has a neutral charge. That means it has no electrical charge. And there's also protons, and those are positive, so they've got a +1 charge. And then around the outside of the atom in the shells, that's where we find the electrons, and they've got a negative charge, which you can see in this table, which we did last lesson. And we also learnt that protons and neutrons are the same size, so we give them a mass number of 1. We also learnt about the radius of the atom and the mass. So we're going to focus more now on using the periodic table, and so this skill is going to be really crucial for solving literally hundreds of types of chemistry problems that you could face. So you need to be able to identify the group, the period, and electron configurations and ions of elements using the periodic table. You need to be able to describe the 3 types of bonding, which we mentioned on the last video, and you need to be able to show diagrams to show how electrons are arranged around an atom, because they're not just arranged randomly. So this is our second lesson of chemistry, and this is how it fits into the overall module. So we looked at the periodic table last time, and we saw that on the periodic table there are 2 key numbers. There is a number at the bottom, which is called the atomic number, and that tells you the number of protons and the number of electrons, because in an atom that number is equal. And then the top number, the mass number, that is the number of protons plus neutrons. So if you want to work out how many neutrons there are in something, you have to do the top number, take away the bottom. So some examples, here if I do sodium as an example, so the bottom number is 11, so sodium has a proton number of 11, so that's 11 protons, and because it's an atom, that means it has 11 electrons. And to work out the number of neutrons, we do top number, take away bottom number, so you should be able to see that it's 12 neutrons. Let's do a little tricky one. If we look at hydrogen up here, hydrogen, the bottom number is 1, so it's got 1 proton, and that also means that it's got 1 electron. Now if you look carefully, remember to work out the number of neutrons we do top number, take away bottom number. So the answer isn't 1. Hydrogen actually has no neutrons, it's just 1 proton on its own. So little trick one from there. Okay. We also learnt that metals are on the left of the periodic table, non-metals are on the right, and metalloids are in this space here in between. So looking at more things about the periodic table. So the periodic table is made up of groups and periods. So the groups go along the top of the periodic table and go down. So if I just show you this one, you can see the numbers written on your periodic table that you'll have in your exam along the top. These are the group numbers. So everything in this column is in group 1. Everything in this column is group 2. We miss out this section in the middle. This is the transition metals. So these are all metals, but in terms of groups we're going to ignore these for your GCSEs. Then we've got group 3, group 4, group 5, group 6, group 7, and the last one, which is group 0 or group 8. Okay. The periodic table also is made up of periods, so you can imagine these numbers being written down the side. Don't miss out the first period, which just has hydrogen and helium in it. Then you've got period 2 going across, period 3, and so on. And what these numbers relate to we'll understand when we've looked at electron configurations, which we'll get to in a second. So you need to be able to identify the period and the group of an element. And the reason is because anything that's in the same group, so for example lithium, sodium and potassium, these are called the group 1 alkali metals, and they all react in a very similar way. They all behave in a very similar way. For example, group 0, the elements here are called the noble gases, and they are all the same in the fact that they don't react with anything. The other thing that's important, which I'm going to mention but I'm going to explain more later, is the group number along the top tells you how many electrons are in the outer shell. So the group number tells you how many electrons are in the outer shell. The period tells you how many shells there are, which we'll come back to in a minute. So electron configuration. So we said electrons don't just sort of exist randomly. They will arrange themselves in the lowest energy level that they can. So if you imagine we've got our simple atom with our protons and neutrons in our nucleus and our electrons in our shells, you can see that there are numerous shells. Okay, the first shell, second shell, the third shell. Then these arrows don't match up correctly, that should point to there. Okay, so if you look at each shell, you can see that in this first shell there is just 2 electrons. So the first shell can only hold a maximum of 2 electrons. After that, that shell is full. You can't fit any more electrons into it. So then the electrons have to start filling the next shell. So if I had, like in this case, 10 electrons, I've got 2 here, and then my 8 go into this next one. So this second and third and all the shells after that, as far as you're concerned, can hold a maximum of 8 electrons. So both the second and third shell can hold a maximum of 8. You're expected to be able to do these kind of diagrams up to the first 20 elements, so you're never going to deal anything bigger than that. So you just remember the first shell can hold a maximum of 2 electrons. After that, they can all hold 8, and once they've filled up, they have to then start a new shell. So there's lots of information you should be able to tell us about different parts of the periodic table. So you should be able to tell us the symbol of a different element if we told you the name, how many protons, so in little number, how many electrons, which is equal to that, number of neutrons, top number take away bottom number, electron configuration, which we'll get to in a second, what group it's in, what period it's in, whether it's a metal, a non-metal or a metalloid, and then eventually, which what we'll get to, is the charge, but I'm just going to leave the charge for a moment. Right? So if we take an example like lithium. So lithium on the periodic table has the numbers 7 and 3. So this tells us that it's got 3 protons, 3 electrons and 4 neutrons. Now when we do an electron configuration, the only number I care about is this one. So I know that lithium has 3 electrons. So if I'm going to draw a lithium atom, I can just put the symbol for lithium in the middle to show where the nucleus would be, and I can draw my first shell. And I draw electrons as either a dot or a cross, and I'm going to do it as a cross so that it stands out a bit. So lithium has 3 electrons, so I can put 1 in the first shell, 2 in the second, in the same shell. I can't put all 3 into this shell because we've just said that the first shell can only contain 2 electrons. So what I have to do with that third electron is I have to put it in the next shell like that. So the electron configuration for lithium, we write it in a really simple way. I write 2, because that's how many are in the first shell, comma to show the next one, and then 1 to show that there's 1 electron in the outer shell. Okay, let's just do another example. So if we do magnesium, so if you look at magnesium, you'll see there's 2 numbers, 24 and 12, and it's the bottom number that we're interested in, so that tells us it's got 12 protons, which means it's also got 12 electrons. And it's also got 12 neutrons because we take top number and take away bottom. So magnesium, it's got 12 electrons in total. So you ask yourself, how many can go into that first shell? Well, only 2. So I can put 2 electrons into that first shell. That means I've got 10 left. Now remember, each shell after that can hold 8. So I've got 10 left, so I can put 8 of them, 1, 2, 3, 4, 5, 6, 7, 8 into that shell. And I've still got 2 left, so I have to put them in the next shell. Just add another shell, and I can put 2 electrons in that shell. So the electron configuration for magnesium would be 2, 8, 2. And if you look on the periodic table, you'll see that magnesium is in group 2, which is why the outer shell, there are 2 electrons in its outer shell, that's why it's in group 2. If you look at lithium, you'll see that it's in group 1, because it's got 1 electron in its outer shell. The other thing that you can check on the periodic table is what period they're in. So you can see here that lithium's got 1, 2 shells, and that's because it's in period 2. If you look at magnesium, you'll see it's in period 3 because it's got 3 shells. So there's lots of information you can learn about electron configuration. The last thing to be aware of about using the periodic table is the ion that each of the elements will form. And we're going to mention this very briefly now. Let me just get rid of the ink. So, in terms of the ions that these form, we've not mentioned ions so far. We've talked about atoms, and in an atom we have the same number of protons and electrons. So if I take boron, for example, boron has 5 protons. Remember, protons are +1, they're positive, and 5 electrons. So because these numbers are the same, in an atom, overall the 5 plus protons and the 5 minus electrons cancel each other out. So overall, boron doesn't have a charge. But what these atoms can do is they can lose electrons, and when they do this, they will get a charge. So for example, everything in group 1 here, we know the electron configuration is, for lithium is 2, 1, sodium would be 2, 8, 1. They've all got 1 electron in their outer shell. So what atoms want to do is they want to have full shells. So it's easy for lithium, or any of the elements in this group, to lose that 1 electron. And when they do that, if you imagine lithium has 3 protons, and at the moment it has 3 electrons, if it loses 1 electron and just ends up with 2 electrons, then overall it's got 3 positives but only 2 negatives, so it will form a +1 charge. So each of these elements can form an ion that is charged, and that's what an ion is. It's a charged particle. So lithium is +1, so anything in group 1 will form +1 ions. Anything in group 2 will lose both of their 2 outer electrons and will form +2 ions. Group 3, +3, we miss out carbon in group 4 because it's not going to form ions. And then at this end, rather than lose electrons, it's easier for these elements to gain electrons. So nitrogen can gain 3 electrons and form a -3 charge. Oxygen can form -2, fluorine -1, and this group here is 0 because it won't form any ions again. So just being able to remember that anything in group 1 will form +1 ions, anything in group 2 will form +2 ions, and so on, that's a really useful skill. The last thing to note is that anything in this part here, the transition metals, you can always assume that they form a +2 charge, with one exception, and the exception is silver, and that forms a +1 charge. But for your entire GCSE, all of these will form a +2 charge unless it's silver, where it's +1 charge, or unless you're told otherwise. So that's a lot of information about ions. So there are other videos that you can watch about this, because it's really important that you understand this skill and how to use the periodic table. You should be able, by the end of this video, to fill out systematically this table. So if you want to have a look at it and think about each of these stages, you should be able to do that and describe lots of the features of each of the elements.